The next presentation is about automated end-to-end vulnerability management by Andrew Wade. Andrew, are you ready?
Yes.
Okay, so feel free to share your screen.
Okay. So my name's Andrew Wade. I'm new to HP. Just been here for 2 months, and before that, I came from as a customer doing OO development. So I'm here to talk to you guys about the automated server patch management. So this is basically any enterprise or any customer that has to patch all their servers. There's a lot of stuff with patching, with creating change records, knowing which servers to patch, disabling monitoring, working with the application, bringing it down, bringing it back up, running QA tests on the application to make sure it's good, and then other things like taking node out of rotation in the load balancer pool. So what this presentation today is going to show you is I took the complex process that all the enterprises have to go through with patching all these servers, and then I automated all the pieces together and I made it fully scalable. So with this, mainly using server automation and operations orchestration, and this came from trying to push on the DCA product set, but since we're able to use operations orchestration, I'm able to drive really complicated logic by using OO as the business engine to make all the decisions and then do the integrations to provide the full automation against all the integration points. So what I'm going to show you today is two main modules. So to do automated patching of servers, you first have to figure out what servers you're going to patch. So there's two ways you can do this. The first way is if the customer wants a fully automated system, totally hands-off, what we provide is the ability for OO to integrate with their CMDB. So in any of the customer environments, they have a CMDB with a list of all their servers. So it could be HP CMDB, other providers, or they just track it using a database, something like that. And for every server, they always define what the patch window is for that server. So what I'm going to show you first is the automated scheduling. So I've set up a CMDB within my own environment. And in OO, what I'm going to run first is the patch forecast. So the idea is OO should on every day query the CMDB and say, hey, give me a list of all the servers that you have that need to be patched in the next 24 hours. And then we'll take that list and go ahead and schedule it within OO to be patched. So I just launched the flow. So what it's actually doing is, so this flow requires no inputs because it integrates, in this case, with my own database. My database has a list of all the servers in my environment, and it also has the patch windows for those servers. So it gets a list of the servers that are in our CMDB database and listed as need to be patched between right now and 24 hours from now. It integrates with HP Service Anywhere, our internal change ticket system, opens up a change for that actual patching process that's going to happen, and then schedules the patching and operations orchestration. So as far as the customer is concerned or someone else is concerned, this runs automatically, and it queries their CMDB every 24 hours, gets a list of the servers that are scheduled to be patched, and then schedules them in OO during their appropriate time. And then further, it creates the proper change request. So the next thing it does is it also has showback. So whenever it's ran, it's going to send out email notifications. So in this case, you can see I have about almost a dozen servers, and those guys were all scheduled to be at this time. So this was all from my internal database. And from a customer perspective, their CMDB would say the same thing. It would say this Tomcat server CI has a patch window of this date. So that way, this automation goes in, grabs the ones that are supposed to be scheduled in the next 24 hours, and then sets them up in the OO scheduler. So that is great. And the next mode is someone just wants to patch their server ad hoc. So I'm going to show you that one next. And because the servers were already scheduled to be patching, when I actually run an individual patching job, I'll be able to show you the same thing that's happening as if the time for the automated scheduling kicked off and the server started patching. So part of the self-service is we wanted to showcase the fact that OO can integrate into other catalogs, whether it's CSA or different dashboards. So since OO has a full REST API, you can easily integrate calling the flows via curl or an API call through REST, which is also like curl. So I'm going to pick 2 servers in my environment, and I'm going to tell it to go ahead and patch those 2 servers. And I'm just doing it through CLI now, just because that's part of the way we wanted to show customers with integration being able to execute OO different ways. So we can also execute it through the web interface if we wanted to. So these 2 guys, the first one is a Windows server. It's an SQL server, and the second one is a Linux Apache server. So my entire patching platform is cross-platform. So it works on any of the flavors. So what's actually happening? So after you start patching for a particular server, he's going to first send notifications saying that the server maintenance is going to start. So you'll see that the first thing he does is say, this is the scheduler just saying we invoked that particular server. So it'll come in 1 second. So we'll give it 1 second. So he sends out the start notifications. So the reason that's important is the servers can have application team owners, server owners, and other stakeholders that want to be notified before a server is being patched. So naturally in the customer environment, we would be able to read their CMDB and say, oh, this server is owned by this person and this group. So we would send those email notifications to those relevant groups. So the next thing he does is check for whether or not the change is open. So with each one of those patching jobs that we're starting, we're also opening a change record. So as you can see, this email came in saying, hey, our server patching is going to start for this Windows Microsoft SQL server, and he integrated with ServiceNow, or sorry, Service Anywhere, just because I had Service Anywhere access for this demo. And he went ahead and opened a request. And in this request, he listed the CIs that were going to be patched. And throughout the life cycle of this patch management, he's going to go back into the same change record and then update the change record with where it's going to be. So once it's finished, if it has an error, it's going to update the change records. So the next area it goes through is monitoring. So I have integrations with SiteScope right now. So I have a bunch of monitors set up for my servers, and the Apache server was here and the Windows server was here. So what it did is it went into SiteScope and also disabled the monitor for that server, so that server is out of monitoring during the rest of the patching process. And the next thing he does is we have a security scanning tool called NextPost, and he's integrating with NextPost via API and running a security scan. So we can also follow through the run over here, and we can see he's going through each one of the modules. It's a little bit easier to see in Studio. So after he checks the change ticket, he actually runs a pre-patch server health information. So what he's doing is for, if it's Linux or Windows, he is authenticating to the box, making sure that the box is up and running, and then he's getting information about the server. So for Windows, running WMI calls to get various things such as manufacturer, the operating system, the last uptime. On Linux, he also grabs the same information. So this is for later report back. And after he finishes running security scan, the next thing he runs is the application availability checks. So for each one of my applications in server automation, I've also created stop and start scripts that get ran before and after the server patching. So you can see in this instance, we were running the Microsoft SQL Server as well as the Linux Apache server. So I have pre-written, so for the Windows server, Microsoft Services WMI calls to stop the actual SQL Server agent as well as the Microsoft SQL Server process. And then the same thing in Apache, we just have a simple stop HTTPD. And then after the applications are stopped, we move forward to actually patching the OSI through server automation. So the other thing I want to talk about is in OO, since we're able to implement more advanced logic, I have something called the patching window timer. So one of the key things in enterprise patching is you want to make sure that no changes to the server happen outside of that change window. So when we actually start patching the server, the CMDB is going to give us information about the change window. And we're going to actually set the duration. So for this one, all my changes are based on a 2.5-hour window. So this would be overwritten as a flow variable if it had a larger window or a shorter window. And now each one of these runs constantly checks the time to see if he's exceeded that window. And at any time, if anything fails, we run through an exception route. So if the server is not up, we log an exception and then start the applications back up and then open up incidents. Or if we can't disable monitoring, we run the exception route. So we make sure that anytime there's a critical error, not only do we update the change ticket, but we also open the correct incident and we dispatch it with all the information needed. So once the actual server has been patched, so it simply runs through server automation and it runs the appropriate patch policy for Windows or software policy for Linux to give the proper updates. So after he finishes doing the actual patching, he will then go in and do a managed reboot. So one more thing before I get there. So since server automation is a core component of this patching framework, inside my patchOS, I made sure that the server automation agent is installed and working on the box. And if it isn't working, I run through workflows to automatically go in and then install the agent and get it registered on the core so that that server is ready to be patched through server automation itself. And each one of my workflows, I'm also capturing the result of whether or not each module worked. And I'm going to get to the showback for that in 1 second. So after he finishes applying patches, this will take a little bit, so I'm going to jump ahead. He'll run a reboot server, and then he's also always checking the change window timer to make sure that after the server is rebooted, it's not waiting for the server to be back up infinitely. So you can see that after we run the reboot, we go in and we wait for the host to be available. And we have a timer to make sure that we don't wait too long. So this timer makes sure that we're attuned to our change window and we don't exceed the change window. If we did, we're going to exit this particular flow with an error and then run through the exception process and log the information that the patching job failed because the server did not come up for a reboot. So if everything goes well, he runs his post-connectivity testing. So this is where he goes ahead and identifies that the server is a Windows or Linux server. And based on that, right now I don't have too in-depth checks. So I just check SSH to figure out if he's Windows or Linux. And then I also do a ping to make sure he's up. So this could be more verbose in customer environments. Uh-oh. RDP. So after the server is back up, the next thing he'll do is run his start application workflows. So the idea behind this is that you usually need to stop your middleware as well as your application. So this module represents the ability for a customer to get as in-depth as they want. Right now I just have it for simple services such as Apache, Tomcat, MySQL for the Linux side, and then for Windows side only implemented Microsoft SQL Server. But the idea is you can expand on this and start doing application identifications. So if you knew this server was a particular application server and your application server admins gave you maybe a REST call to verify that the application is up and running properly, then you would simply be able to add that workflow here so that we could do the in-depth after the application starts up or the middleware starts up application QA smoke tests. So you can start going as deep as you want to make sure that your application is up, and then add the automated remediation of your application. If you find your application isn't up, you may have some restart tests, or maybe the application teams have alternate scripts. So they can host that in their own Git repository, and we can make calls out there so that the ownership of the application QA, smoke test, scripts, and logic is still on the application team, and OO is merely providing the ability to go out there and run it on behalf of them. So after the applications are start up, we run another vulnerability patch scan, and then we run post-connectivity testing, re-enable monitoring. We go back to our change record, update our change record, and then we send out our verification email. So since our particular job, it looks like he finished patching the Linux, but he's patching the Windows. So I'll jump ahead to the completion emails. So, so this is what a completion email looks like. So this is custom HTML I wrote based on all the operations. And this is the OS information before and after. So the idea behind this is you want to see what the server looked like before and what the server looked like afterwards. So you can see this Red Hat box, the major OS kernel didn't get updated too much, but you can see we had a minor kernel enhancement. We took out a lot of the patches just to make the demo speed up a little bit. And next post is our security vulnerability engine that we use, kind of like Qualys, and it does security scans on the box. So I went into each one of the jobs that we ran, and then I parsed out for the actual score, as well as included the actual attachment from the tool to the email itself. So if they wanted to see what vulnerabilities are still available on the box, they would go through here. And then each one of the modules I was talking about, I represented here as an HTML output. So each one of my subflows, I measure the start time and the end time, and also the run time for everything, so that they know that we checked for the change, we disabled monitoring, we made sure the box was connectable before we started patching. And you see the security scan took 5 minutes, and then it ran through stop applications, apply patches, everything all the way up until closing change. So you can see for this box, his change request was this one. Let me move this window. So in Service Anywhere, it doesn't actually prefix. So you can see for this server that finished, he went through all the particular modules to patch the server, stop applications, start applications back up, all the way to the point where he circled all back to the end with the actual request, and then he updated the request itself and posted the time that he finished patching the server. So this one's actually kind of old. It doesn't have that stanza at the end because I just added that in recently. Okay, so this guy actually just finished. He was our Apache server. I had to run him without the next post stand because that takes too long for this demo. So we'll look at his change request real quick. And what we'll see is that after he finished patching, he went into the change request for his particular change instance, and then he updated that the patching was completed and what time it was completed. So that's just showing the customer that we can integrate with any of their change ticket systems and be able to update and provide the lifecycle process through their change management system. So does anyone have any questions? I know I kind of went through a lot.
Yeah, actually, I have a question. I mean, it's obviously not a hack for a hackathon, but in a project and a very interesting project. And the question is if you will be able to show it in a webinar for the community in the future?
Yeah, so I plan on doing a webinar. So my manager is setting one up, the virtual community. I'm still new with HP,
I'm
so
talking
I
about
don't.
the OO
Yeah.
community. We have a monthly webinar, but we can take it online, offline. Anyone here?
Oh, I know what you're talking about. Yeah, it's like once a month
Yeah.
session for all the customers. Yeah.
Anyone else has questions?
Yes, so first of all, Andrew, welcome to HP and congratulations for this work so far. I have a question more specifically regarding the tools that you are using here, or the products, right? So is there any specific reason why, for instance, you use Nexpose versus other tools like or products like Nessus or things like that?
Yep. So originally, the customer I was creating this for wanted to use Qualys, but Qualys only would give me a software as a service offering, so I couldn't download something and put it in the lab environment I was using. Nextpost could, so I used Nextpost. I didn't even think about Nexus or HP's security tool sets because we probably have an internal one. So it was just me trying to develop fast enough to meet an expectation. So we can easily swap in and out the security tools. That's why I keep everything high level in these modules. So here you could just add a flag and say, I want to do Nextpost, or I want to do Nexus, or I want to do your third tool, and then you just tell it to route whichever way you want. So I just chose one. That's the only reason why I chose that one.
I see. Okay, and the second question from me is basically, if have you considered releasing this as HPLN content as well so far?
Yeah, so part of the hackathon requirements is releasing it on HPLN, so that's what I plan to do. Everything I wrote is very it conforms to all the system property things. So everything I use is generic in the flow, and then you just set up your credentials and all this stuff on this particular project, and that lets you deploy in different environments. So the main flow can be easily portable to other places. I just have to make sure I scrub some of our internal password stuff.
Okay, thank you.